All right. So, unfortunately, even though I recorded the lecture today on Tuesday, it got erased. So that's always wonderful. Um, or I should say, to be more clear, it failed to record. So I'm going to redo a few of the things that we talked about, just so everybody has access to them, because a lot of people weren't able to be there for the whole thing. And so, um, one of the things we're going to talk about is the difference between series and parallel. So, um, and this will greatly help for your homework. Uh, for 13.5, that fourth question where you're identifying each circuit as either parallel or series. So let's talk about some of the differences. First, let's go here and you have you picture the charge. I'm actually gonna do it correctly this time. And talk about the electrons flowing from the negative side to the positive side. That is the correct, even though the current actually will flow the opposite direction, and that's why I have them labeled 1, 2, and 3 here, because the current passes through it this way mathematically. The electrons, remember, go the opposite direction. So let's think about what's happening um, as you go around this way. So as it goes around this way, comes to here, and it has a choice. Does it want to do R1, R2, or R3? Remember, the resistances represent how difficult it is, or how much to go through, or how much the current will be slowed down by each resistor. So if you have a choice, this one electron that we're focusing on will either go 1, 2, or 3, and then it will meet up on the other side. Um, it won't flow backwards because remember there's sort of a flow of electrons coming at it from the back, and it will continue going on this way until it ends up at the end of the circuit. So the one of the ways to tell these apart is picture an electron going around the circuit, and it's okay if you forget to start the negative side. It's okay if you picture the positive current flowing and which way the current actually flows. But I like to picture an electron. So if the electron has a choice, we talked about that this is an OR gate kind of, and so it can either go this way or this way or this way, and we don't have to have three. We could have 500 options. We could have two options. The important thing is it has options. If there's just one, it has to go through that one. If there are three in parallel, it can choose one of the three, and it cannot choose more than one of the three if they're all parallel. Okay, so it's as if each one of these is on its own individual circuit with just the battery and just that resistor. Okay, so it's like you have, let's say you have, um, you have your battery, and then you have this one circuit here, and another circuit here, and then a third circuit sort of coming out of the board and going back in, and you just have these three circuits with their little resistors on them. um, that would have the same effect, right? The electron can go in this loop, or in the other loop, and it can choose. And so that's how parallel works. Is the electron has a choice. Now, as as you're going through the homework, that's how you can tell. Does the electron have multiple paths that it can choose to take as it goes through the circuit? If so, then at least that portion of the circuit is parallel. Let's contrast that with this here. Um, as an electron is flowing through here, it must go through the first one or stop. It's continuing around the whole circuit. Let's just assume that. So it must go through this one, and then as it continues, it must go through this one. There's no choice. And then it must go through this one, and then it ends up back here. So what has happened? It had to go through every single resistor. It didn't have a choice. Um, And so this is, as we mentioned, this is like an AND gate logically or computationally, where you have resistance 1 and 2 and 3 all working in the same circuit to resist the current together. Um, so so let's think about this. This only has one path. Let's picture a river. Okay, there's only one channel for the water to flow down. All of the current is going to flow through that one channel. That seems fairly obvious. Um, so in a series, right, this is a series one, this is the parallel. In a series circuit, what is constant is the current. Okay. And then what's nice is, remember, as you're going through, what happens is this one resists, and then this one resists as well, and then this one resists as well, right? So all three resistors resist the electron as it flows through, or the current as it flows through. And so to figure out the circuit, you add up all the resistances. You add them up. You find the sum of the resistances, and that's the resistance of the whole circuit. But the current remains the same across each one. Okay, let's talk about how that works in the parallel circuit then. Because it's splitting up 1, 2, or 3, they're not in fact working together. In fact, they're kind of competing for who will get the current and who won't. So again, think of like there's a stream, and where instead of flowing maybe down three separate waterfalls that are all in the same branch, maybe this time it has three separate waterfalls where it branches off, and maybe it goes down one branch or another branch or a third branch, and maybe each one has a waterfall. And so that's sort of this one. And so here, the current is split. The example I gave in the lecture was, imagine you have a certain amount of energy to complete a chore, or some sort of task, and your parents are giving you an option. Let's say you can do one of three different tasks, and maybe one of them is sounds much more work for you, and the other one sounds maybe mediocre, whatever. And then maybe the third one is the easiest of them all, and see, well, which one are you going to pick? If you have a set number of willingness to work, um, or a certain amount of energy that you feel like you can devote to doing chores, you're probably going to pick the easiest one. And so the resistor with the least amount of resistance is going to be the path of least resistance, and most of the current is going to go that way. So we said, if you have, let's say, 1 ohm here, and then 2 ohms here, and then like 5 ohms here, this one is resisting the most, so this will have the least amount of current flowing through it, right? Think of this as like the hardest task. And then this one has the least amount of resistance, so it's the path of least resistance, and so most of the current will flow through it. This is just like saying, it takes the least amount of energy to push through this channel, and so most of the current is going to go through there. All right. And this one is going to be twice as hard to get through. This one's going to be 5 times as hard to get through, and so you can kind of match how much current based on how much resistance. So you do not add up the um, the resistance. In fact, they're all competing with each other, and that's really complicated to actually calculate. What you do instead, or what you focus on instead, is that the voltage actually stays constant, because remember I said it's as if you have three separate loops, completely separate from each other. You can wire this up completely separate from each other with the same battery, and as long as it has the same battery, um, it will act exactly the same. So, um, so really, it's like these are three separate circuits that are all sharing a battery, and so the voltage as on either side of this is exactly the same, um, because it's from here to here, nothing stops the actual flow, and so the voltage here and the voltage here are exactly the same. Okay. Um, Instead, what happens is you add up the current. So the current that flows through here plus the current that flows through here plus the current that flows through here is the total current. And you saw this in the excellent video that I put up. So the current, and I should probably just do the actual Ohm's law letters here. So with a parallel circuit, what you do is you add up all the currents and the voltage stays constant. I won't get into how exactly the other one of the two here work, but they're calculatable. What if you know that these stay constant for their respective things, then that's how that works.